My name is Nwoye, and I work with the NHS. And today I will be talking about AI assistant tools and the limitations of these tools. All right. So over the past few years, there has been a surge in AI assistant tools promising self-service analytics. Ask a question, they say any question at all, and get an answer. I know everybody wants that capability, everybody does. But if you've used tools like Databricks Genie, Power BI, Copilot, or even Tableau GPT, you will recognize that they excel at entry-level analytics, such as report summarization, KPI retrieval, and dashboard creation, etc. But while these capabilities lower the barrier for accessing data, they don't actually provide a lasting competitive edge for your business. Now the question becomes, how do we get to that point where we could perform advanced analytics using AI? Over the next 30 minutes, we're going to cover these three key topics. First, why the typical AI architecture limits advanced analytics. Secondly, what is a better self-service approach without exposing live data, and what are the benefits it brings to your business? And lastly, what you can start doing today. Now, what we have on the screen is a typical AI architecture behind most AI tools. For the purpose of this event, we're going to use the Power BI Copilot. Everything starts with the user's prompt. The Copilot analyzes the intent behind the request, and it does this by intent classification. For example, if your prompt contains the phrase like "show me," it's categorized as a visualization intent. Now, for the next stage, which is the semantic model, the Power BI specialist or analyst would have prepared a semantic model beforehand that the Copilot is going to consult to perform what is known as grounding. Now, for those of you not familiar with Power BI, this is what the semantic model looks like. It explains the relationship between tables, but it can get messier, especially when the tables are so much. Now, after that bit, it does the grounding. And in this process of grounding, it basically retrieving known measures. Let's say your company has a specific way that they calculate net profits. It does that. It retrieves that data or that metrics. And if you have like tables, columns that you need somebody to be able to see, or somebody is authorized to see, it allows the Copilot to retrieve those information. Then it formulates a new prompt similar to what we have on the screen. Now, this is the initial prompt. Then the Copilot makes up this. Then it finally sends it to the large language model here. And I like the fact that it does all this process before sending it to the large language model, because then the prompt might contain sensitive data. In the process of grounding, it makes sure that no sensitive data goes through to the large language model. Now, finally, the large language model takes the prompt and formulates a result, and the Copilot validates that result. If it needs to execute it against a database engine, it does that, then return a final output to the user. Now, this architecture works, but only to a point. Let's look at some of the pitfalls. My voice seems to be a little bit louder now. Let's look at some of the pitfalls. The first is that the large language model is treated like a function. Pass, parameter, get an answer. But here is the catch. The large language model itself isn't trained on your business data. So if you just give it a little context, It can like improve the sort of results it presents to you. But if you give it just enough context, then you could do amazing things. And I believe given the amount of billions spending on the large language model, you should use it to reason more deeply than just using it as a function. Now, I know in the future, Microsoft might allow you to sort of fine-tune the large language model that sits within a Copilot. But trust me, that will be, for anybody that has done any fine-tuning of a large language model, that's an expensive project to handle. Now, the next is poor scalability. Imagine that you have to build a semantic layer for all the tables in an entire organization, like across the whole organization. In the NHS, a single trust could easily have like 2,000, 3,000 tables. Neil would know this given that he works with different NHS trusts in their data migration project. Imagine having to build the semantic model for those tables. It's a bloody nightmare, and the columns are constantly changing. So it becomes unbearable to handle over time. Now the next pitfall is the platform lock-in. I was speaking to someone earlier and I told them that Microsoft does a very good job in locking you in the moment they catch you. And let's say Amazon or Google emerges as the dominant force in the AI war, and you have to migrate that tightly coupled semantic layer, or model, sorry, to another platform. It's like you're redoing the entire project, but more painfully is the fact that you're moving to another platform just to get locked in again. Understand? So it's very important that you think about that as well. Now, the last thing is that data is treated as a byproduct of a system. Now, the architecture we saw earlier increasingly treats data as a byproduct, but not a product. And a product is supposed to be accessible, trusted, understandable. It does a very good job in making it accessible, but not trustworthy and understandable. Now, that brings us to the important question: what would a better self-service approach actually look like without exposing live data? I'm going to digress for a minute and show you what it actually means to give the LLM just enough context without exposing live data. Has anybody here ever used the Google Notebook LM? All right. So if you're not familiar with the platform, it allows you to upload your data source, and the large language model will use the data source as a context to answer your prompts more correctly. Now, let's say we had two tables, the patient activity table and the care coordinator assignment table, and we needed to return the care coordinator responsible for a patient activity. Looking at this table, immediately you would suggest I join it on the patient ID, given that it appears in both tables. And the reason why I say this is because in my team, one of the junior developers had the same task, and they joined it on the patient ID, and they ended up with a wrong result. But thankfully, we have a very good test framework that ensures errors like this don't go into production. But here's the problem with this table and joining it on just the patient ID. You can see that the patient 100 was assigned to both Alice Johnson and Bob Smith over time. So the moment you do the join, you end up with a many-to-many relationship. So it's very important that whenever you're joining your tables, you think about that every time. But let's see what happens if we give the LLM just enough context without exposing this data to the LLM. Now, this is the result, obviously, you're going to get, which is wrong. We want to give the LLM just this context. A data dictionary telling it the different columns in the patient activity, the care coordinator assignment table, and the relationship table. Now, this is very important. Instead of having a large semantic model showing the connections between tables that nobody actually understands except the Power BI specialist and the AI Copilot, you should Also make sure that in your organization you have something like this, easily explaining that this table is connected to that table in a very structured manner. Now, I'm going to upload, or what I did there was to upload the link to that document that we saw earlier. So this is like a Word document. Upload the link to the Google LM notebook, and I'm going to prompt it, asking it, generate an SQL code that returns the patient activity and the care coordinator responsible for that activity. And you could see what it says. Mind you, it doesn't know the context of our data so well, but it has just enough context without exposing the live data to it. It did a good job in joining the two tables together very well, but more importantly, making sure that for a patient to be linked to a care coordinator, that care coordinator must be active at the time the activity occurred, which was what the initial query was missing. And now you end up with a good result. And it also explains the reason behind the join and also the response and all the details, just telling you, okay, this is what I did to arrive at this answer. So it's very important that whenever we're treating AI, we want AI that gives us context. And also we want to give it just enough context so that it could answer our prompt more correctly. Now this is the final prompt, and you have a good result that shows everything checks out. Now, what is this better architecture that I speak highly of? Some of you might have guessed it right already. A centralized catalog, an AI-powered centralized catalog. There are so many centralized catalogs that are out there already, but they are not built with AI and humans in mind. Mostly are just built for humans, but this is a centralized catalog with AI and humans in mind. You want to have a semantic layer, not a semantic model, that makes data understandable to both humans and AI. Like in the NHS, you generate a report, you send it to a clinician, but the clinician will look at the report. She doesn't understand how you're arriving at these answers. She can't question the report because you're not giving her the logic behind it. So imagine that you have a catalog that explains, this is what I did to arrive at this report. The clinician could just go and be like, no, you shouldn't calculate it that way because we don't do it that way. And it's very important that we begin to treat data as a product, a structured documentation process for each data set we are producing. So that anybody that picks the data set, be it an expert or somebody that isn't techie, would immediately understand what you're doing to generate that data. Now, the only difference between this architecture and what we saw previously is the fact that instead of consulting a static semantic model, the large language model is being fed pages from the centralized catalog as context. And it does this by, when the user makes a prompt, it converts it to serialization numbers. So let's say a user makes a prompt, show me something. It converts it to numbers. Then in your catalog, all the pages in your catalog have been converted to numbers and stored in the vector database. Now, anytime you make a prompt, it picks the page of that catalog from that catalog that is similar to the prompt you're making and supply it to the large language model. So the large language model has enough context without exposing live data, which is very important because then you could look your customers in the eyes and tell them that I'm using AI, but the environment is entirely different. You understand? We store data in one environment and we have our AI workload in another environment, which is like in the healthcare industry, is a very big thing to provide that assurance to patients that you're not exposing their data to AI. Now, this is the kind of context it is applied to the LLM and finally generates the result, validate it, send it back to the user. Now, here are some of the benefits. Like I mentioned earlier, you have the hard separation between AI and live data. The second thing is that AI is treated as a product. We're no longer treating AI as a byproduct of a system, but as a product. It's like when you buy something, you get that prescription note or that, you understand, template, pamphlet that explains what that product is doing. That's how you should treat data, especially in the data engineering space. You want to give your users explanation of what is happening, how you're getting it. And it's possible from the technical perspective, you're doing it right, but from the business side, it's wrong. You understand? And those executives or clinicians or people that don't know anything about tech, they could have a very good understanding of how the data should be working, and they would correct you immediately. But if you're not giving them that context, explaining what or how you're generating that data, you're just shooting blind, basically. The second is that you have a single source of truth for your data knowledge. So most people in organizations, especially in the NHS, you have files, PDF everywhere, like scattered everywhere. Now bringing everything to a centralized location, that makes it very easy for anybody to discover that document, check whatever they want to check, analyze it, but then you have a very unique place that you store, or a centralized place that you store your documentation. The next benefit is that competitive edge I'm talking about. Let's say, for instance, Adams, we know this very well, given that he does like ML workload. If you want to train a model, in a way, you're not just going to supply. It's very easy to say, oh, give it data, but actually data doesn't come plain that way. Data is messy. So you want to gather all the context around that data and supply it to the LLM to also understand, okay, this is all the possible things that could go wrong. And this is the difference between your business and another business. People are just building, let me say, centralized data location, but you're also tracking all the lineage, all the data quality issues around your data. You're documenting this process. Over time, that becomes a very big asset. If you want to train a model, it's very important that you bring all those things to play to get a very good model that gives you a very high percentage prediction. Another benefit is the fact that knowledge persists beyond individuals. Before now, people spend 20 years in one organization, but that's no longer the case, you understand. 2 years, 3 years, 4 years, a person has moved on to a new organization. So you want a centralized catalog where everybody puts down their knowledge, anything they discover around the data, they put it down, so that if somebody comes on board, you can easily point the person to the catalog and say, all right, go ahead, read this. I think it should give you everything you need. And definitely it does, because it's a very well-structured, documented platform that the person would see everything they need, all the data quality issues, when it was discovered, how it was solved. You're basically treating data as a product, like I said earlier. And the last thing is you avoid platform lock-in. Because with documentation, it's your property. So Microsoft won't tell you, you can't move the semantic model to Tableau or something. No, your documentation process is your property. And the good thing about the architecture I showed you earlier is the fact that it's composable. So if, let's say, Amazon comes up with a very nice language model, you could just plug and replace that model. Now, that brings us to the last topic of the day from my end, what you can start doing. So I've prepared an ebook that I would send to the organizers, and they would send it out to everybody that has attended the event, that explains all the things that you're supposed to do. But just to give you context, so the first thing is to take stock of it. It's serious business. Like, you have to treat this thing as a serious business. Everything, all the data assets you have, you want to understand everything it is doing, what depends on what is related to what, who owns what. You want to track all that information, and you want to document it. is very important. And these are some of the things that you want to make sure you're capturing when you're doing that. Data quality is very important in the sense that you want to see over time the kind of data quality issues you've been having. Because it's one thing to solve that issue, but it's another thing to understand why is it reoccurring every time. Then you could go back to where that issue is coming from and just change it or stop it from happening in the future. Now you want to also have trust and certification for your data. So when you produce a result or a table, you want to say, this table has been tested, maybe validated by the data engineer, the data analyst, and the data scientist. And you have, it could be a green flag or something saying that this particular data set has been tested and trusted. So even if anybody's looking at it, they know that, yeah, the column where this is coming from has been tested, or the view or the sprog that generates this data has been tested. Now, the last and important thing I want you guys to do is to appoint someone solely responsible for maintaining that catalog. There is a saying in the Igbo culture that goes like this: a security dog that is owned by the entire community often goes to bed hungry because everyone thinks that someone else has fed the dog. So it comes back to what we are discussing. If you don't have somebody responsible for maintaining your catalog, everybody thinks that somebody is doing something about it, and nobody is actually doing anything about it. So you have to get somebody. It could be a technical writer that understands the basis of programming and all those test framework, but you want to appoint somebody solely responsible for handling that catalog and making sure that you maintain it over time. Because documentation, yes, you could easily start, but after a time, it gets left on the sidewalk and you don't pick it up, and maybe 3 years later, you'll be like, oh, 2019, that was the last time it got updated. But if you have somebody that is responsible for that process, then you could hold a person accountable, like, oh, why is this not updated? What has changed? So, yeah, if at any point you have any question for me, I'm more than happy to link up. But it's been a pleasure sharing my knowledge with everybody here, and I wish you guys, it's going to be an early lunch, so I wish you guys a wonderful lunch and enjoy the rest of the event. I'm more than happy to answer any questions you have for me. Oh.
I just want to say, as somebody who's been involved with metadata repositories and data models on and off for several decades, finding somebody who wants to buy the dog food is the biggest problem. Nobody wants to pay for it.
Yeah. It's good that you mentioned that, because most times people are just focused around the actual data, but forgetting what does the data actually mean, or what does the data model actually mean. And some people going into contract will be like, yeah, the vendor will say, we won't supply your data dictionary. What the hell? Why won't you give me my data dictionary? Like, you have to provide my data dictionary. So it's all these things that makes it very easy for you to start doing advanced analytics, because you have your data dictionary, you have the lineage around your data, and the sort of documentation. Yeah, well, thank you so much. Yeah. Any more questions? All right, the gentleman over there. Oh, okay. Go back.
Firstly, thank you for the talk. It was very informative.
Thank you.
So you mentioned earlier in your talk that one of the purposes of a properly maintained catalog is, or at least one of the benefits is that it provides the LLM or the tool that you're using with an understanding of the relationship between the data tables, for example.
Yeah.
So assuming that you're using one of many solutions, maybe you're deploying your infrastructure as code, your database infrastructure, or maybe perhaps not. Maybe perhaps you're just keeping your table definitions in source control. Can this be something, it's like instead of preparing documentation for the LLM itself, can the table definitions and the code itself be used, be provided as a context for the LLM? Because it's given access to the table definitions, should be able to make that relationship, knowing what the unique identifiers are and what exactly the relationship between the tables is.
All right. So to answer your question properly, I'll just go back to the slide where we saw the catalog page that I mentioned. So you don't get this sort of information in a table definition from your database. The only thing you get is the fact that the column is a string or a timestamp, but it doesn't explain the kind of data that is in that column. So it's very important that not just the definition, but what actually is that column containing, like what kind of data is it capturing? That's why this documentation process is very important. You understand? You explain what each column is doing so that anybody that picks up your catalog will understand that, yeah, the activity timestamp is talking about activity of when because then this could be misleading sometimes, the naming conventions, but you want to have that document that explains what it does. But again, like you mentioned, it's a very good point you raised, having the code, presenting it to the LLM, and it's very important also to do that. Hopefully I would get Neil to endorse the idea of this centralized catalog, but in the complete architecture, it covers even down to the template format that the catalog should be in, because it's a research I did, and explain all the things you should be capturing. And you could also include like a snippet of the code to show this is what you've written, and the LLM could look at it and be like, yeah, well, I'm going to give you something better, or what if you test it using this framework? Because it's very easy to write a code that has been there for a very long time and producing wrong results, and nobody knows because maybe something in the data has changed that needs the code to change. But if you have like this centralized catalog that is designed for the LLM, what it does is that if anything changes in this place, you could easily understand that that code needs to change, or the LLM understands that that code needs to change as well. Because maybe what you're capturing, like in the NHS, we have these hard-coded teams. You could say, okay, we want to bring back data from these teams, but not this one, or from this ward, but not this one, or from this hospital, but not this hospital. Those things are hard-coded in the code. So having that in the catalog is very important as well. Yeah. Any more questions for me? Oh, thank you. Or you could use mine, yeah. Don't worry.
You have mentioned vectorizing the data is going to save us from the sensitive information, like if we do it. But vectorizing is not the encryption. So vector is a code.
Okay. So going back to the architecture itself. Now, the design of this architecture is that you want your documentation to be stored in a normal structured database. But for the LLM to access the relevant documentation, you want to convert it so you could store it in the vector database. So remember what we are doing is the documentation. The live data is not in this architecture. These are documentation. So you're not even, the conversation of sensitive data doesn't come into this one, because what you're writing here is the metadata, the process, and other sort of things. But now, how does the large language model retrieve that as quickly as possible? You have to convert those pages into centralized, into a vector, and put them in a vector database, so that anytime you make a prompt, it just goes pick the pages relevant to that prompt and supplies it to the LLM. Because we don't want to dump the whole catalog every time somebody makes a prompt to the large language model. So it picks the relevant pages to the LLM. So that's why we have this vector database. But this one would actually hold like the normal data in the catalog. But this one converts it to vectors and stores it in here. Oh, thank you. All right. I'm loving it.
Just a rider onto that. If you're in your centralized catalog, you had information about under what circumstances people are allowed to access certain data. The answer could be to the prompt could be, you're not allowed to ask that. Because let's say you're in the NHS in Chiswick and you've asked for patient data from a hospital in Leeds. It might be the kind of thing you're not allowed to ask. So the centralized catalog will have rules in it. Say, if you're in here and you want to access this kind of data from there, no, you can't, possibly just because it says so in the law. Or it's, if you're accessing, one example I've seen is where you're trying to access data, you're in Colombia and you're trying to access Venezuelan customer data of a particular kind, and you have to look up the Venezuelan and the Colombian data protection regulations and your own internal rules to see whether you can even ask the question. Never mind get the answer. So the centralized catalog could be a lot more complicated than just a data dictionary.
And given what you just said, it's also very important to mention that in here is your data or the business process entirely. What anybody is allowed to see, who owns what, who owns that data set and other sort of things. But this is just for an organization. It doesn't cut across bringing data from different organizations. But what this is actually doing, because then when you design a tool, it's very important that you define what the tool should be doing. The main purpose of this tool is to provide clarity on what data sets we have in the data system or in our organization, explaining what each data set is, but giving the large language model enough context to understand that the patients could have multiple care coordinators over time. And if I'm going to create an SQL query that returns the patient activity and the care coordinator activity, I have to also ensure that I add those conditions that make sure that the patient activity falls within the period that the care coordinator is active. Normally, in some organizations, there are so many like lines of code that have gone unchecked. I've errored so many reports because you're not exactly describing those business contexts. And if you can't describe it, the large language model, if you supply it, this data dictionary could spot those for you to tell you, oh, you should be doing this or you should be doing that. So see it more as an advisory, like sort of advise you on what you should do than goes out there to fully extract the data and push it to another maybe system and bridging governance and other sort of things. But yeah, you could have those processes and those governance conversation in the centralized catalog. But again, people could look at the documentation and be like, yeah, we're supposed to do this or we're not allowed to do this. But basically just a centralized location where you document your processes and data. But again, the AI understands it. So you're building it for both humans and AI.
Thank you, Stephen. That was really, really good. You covered so many points, and I was wondering, what is your approach in terms of data retention compared to the data retention policy that you've got in the source system?
So it goes back to the contract around your data in the sense that this is how long you want the data to be in the system. But that conversation depends largely on the organization itself. Like, what is your policy around it? You can't just make up the policy. So you have to go with what the organization is using. But again, bringing it back to the topic of the catalog, let's say you have a particular data set that needs to be checked every month. Having it in these systems helps the large language model notify you that you should check this data to see if it is due review or something. So yeah, it depends largely on the organization, but more importantly, having that documentation that says this is how long it should stay, or this is when you should review it or not. Any more questions? Oh, thank you. All right.
Thank you so much for your presentation. I was thinking about when trying to implement this, like, would you recommend first, like, focusing to do this within data analytics teams maybe, and then trying to like broaden the scope within maybe non-technical users? Like, if you could share a bit of your experience maybe, that would be great. Thank you.
Thank you. That's a very good question as well. It's very important that when you're starting out the data engineering process, the data modernization process, you start from the engineering bit. Because just like testing, you want to test from injection. You don't want to test afterwards. You want, as the data is coming in, you're testing it. So you push it down to the engineering bit, because then it's easier to implement it that way. Because if the analyst is going to start doing this, they would have a hard time explaining what those tables are, what those views are. But if you push that workload to the data engineer, I'm a data engineer, so I'm adding so much workload to us, but push that workload to the data engineer to start with, and they will bring out that like sort of template document that the analyst could start adding onto. So the approach would be that I would suggest is start with data engineering team. The modernization should start from the data engineering team, documenting the process of how those tables are being generated and what those tables are. Then the analyst will now be explaining the kind of calculations and the kind of matrix they are calculating and how they are calculating it, and the sort of business context and the text specification. Then they are making it usable for the business users or the clinicians or anybody that is using it. So start from data engineering, analysts, then to the people using it. That would be my suggestion, yeah.
Okay, I've got just a comment. It's Keith here. You mentioned in your table format having the description against the varchar or the string column. You know, it's a little thing, but databases have not had that information filled in. They've had the ability to put comments on columns, comments on tables, etc., for over 20 years, 25 years, yet it rarely was done. Hundreds of our customers, and we're a database company, hundreds of our customers don't even know the feature is there. Yeah. So whilst it's a really great thing to try and put out, this is a comment, not a criticism, the maintenance of these catalogs will get out of date. It will lose data quality unless, as you pointed out, there is somebody to maintain it and feed it. And that is going to be the big kicking point that AI may fail. You know, anybody here who's introducing AI, if you haven't got the persistence today, and you haven't had the persistence for 20 years, why are you going to do it now?
No, yeah. Thank you for that comment. It goes again to explain the sort of hard work that goes into being AI ready. It's so much hard work. There's no magic to it. For you to get to that stage where AI could do so much for you, you have to put in the work. And thank you so much, yeah. Any more questions? Yeah.
Can I just say 2 words? Data governance.
Data governance.
Oh, nice. Nice, yeah.
Wash your mouth out.
That's why I didn't use the microphone.
That's okay. I think this is the old rule in IT, isn't it? Garbage in, garbage out. Yeah. So I think, Keith, you were saying the description of fields and so on, that can be suggested by AI as a help. So you can use that as a governance tool to help put together some candidate descriptions. Mm-hmm. But even then, an example I always like to give is I worked with a customer once that had a system that was so old, it had no column for email in the customer tables. So they repurposed the fax column to store the emails. Now, anyone arriving from outside would just see a fax column and not know that they had to use that one to get the email back. So, you know, data warehouse cleaning would rename the column on the way through, and that's an example of semantic meaning. You know, fax is not fax, it means email in this case. You're adding cognitive load to your developers. Suddenly testing becomes more difficult, which is where that catalogue comes in really at the top end. And you need to put in two types of description. You need to have a contextual description of the concepts in the business, and then underneath that, every system, because some of my clients have 80 systems running, and there's maybe a customer is in 15 of those systems, and it all means something slightly different. So you need to have an integrated view of what a customer is to start attaching things, and then you get this out as a side effect. Good quality data in allows this to work, and also increasingly now seeing sharing of data across players in an industry. Things like Snowflake data sharing, where you can just activate a share and bring data in without transporting it. Again, you need to have this common conceptual understanding of what the data means. And that's the big challenge over the next 10 years. The stuff that Berners-Lee has been working on with Web3 in terms of getting semantic meaning attached to web pages as well. Anyway, thanks. That was very interesting, Stephen.